right, everybody. Welcome to a brief tutorial for Ansys. First things first, I'm going to have you guys load up specifically Ansys Workbench, which is the software we're going to base everything out of. This is kind of a library of softwares and a library of materials, and it'll kind of be the baseline for everything we work on. When it loads up, you'll see over here on the left that this is actually all the studies we can run. So there's a ton of different options, including a bunch of things that are probably more for graduate students, but we're going to focus specifically on static structural. And the reason for this is that's what most of what we're going to do in this class. So I'm going to double click on this guy, and it should load up a little window here. And this window represents kind of all of the things we need to complete our study. So you'll see up on top, it has sort of the materials library, and then we kind of go through and assign the geometry and assign our loading and our meshes and all of the things needed to get a result. For our purposes, whenever you see a check mark next to something in an icon like this in Ansys, it means it's ready to go. And a question mark means that we have to define it. A little X means it's not defined. So keep that in mind as we go through, because that's going to be a pretty common thing you'll see in the menus. We're going to start out specifically by modifying the material library. So I'm going to double click on that. And when I double click on that, you're going to see that we're going to only have one material in our library to start out with, and that's going to be structural steel. Down below, we can see the summary for that structural steel, and it has a lot of information depending on how well researched or how well input the material is. So for example, this is our curve for the fatigue of that material. In general, you can load a custom material whenever you want. You can just literally click the icon below and manually input all of this data. But this is not something we're going to use very often in this class because it's a pretty dense topic. Instead, we're going to go up here to the little icon that's right there. That's going to be our material science icon. And our material library icon, excuse me, and it's going to pull up our material libraries. And our material libraries are basically collections of materials we can use. I'm going to cheat a little and use the Ansys, the Granta pack that's at the very top. You may or may not have this depending on your version of Ansys. And when I double click on that, it'll load up all of the materials down below that I can use. Because we used copper, aluminum, and a polymer in lab, I'll choose those. So I'm just going to choose aluminum and press that little plus mark. Copper, once I find it, and there we go, and press that little plus mark. And then I'm going to just add a polycarbonate just because, you know, it'd be fun. And I know we used I believe it was a nylon in lab, but polycarbonate's a good material to kind of practice with, so I'll throw that in there as well. You'll see that there's a ton of other materials as we go through, and in fact, if you look up here, you can see all of the other material libraries. So you actually can have a lot of fun with playing with materials you may not necessarily get to experience until you're further along in your career and seeing how they react to certain loading. There's a ton of information inside of here. Be aware that loading your own custom libraries is also possible. But yeah, so moving forward, I'm going to go back to our menu and just double check to make sure that our materials loaded properly. So if we check, yep, all three of those materials have loaded properly, so we can move forward. That just means that when I'm doing my study, I don't have to add them later, so it keeps things easy. The next thing I'm going to do is I'm going to load up Ansys Discovery or Space Claim, depending on which version you're using. That in general is going to let me define the geometry. It's a pretty clunky software. I want to stress that going forward. It is kind of an older version of CAD, and you'll encounter that and kind of experience it as you go through. I'm going to use SolidWorks to import files, and I'll show you how to do that. But if you'd like the basics and you'd like to understand it, I'll also cover that as well, just to make your lives a little bit easier. So your choice to make parts is either to make them in SolidWorks or to make them in your Discovery software. So at this point in time, the next thing that we're going to need to do is to wait for it to load. This can take more or less time depending on how VLabs is feeling that day. So once Discovery has loaded, you're going to find yourself in kind of this large infinite volume. And this is where we're going to be doing most of our work today. You can pan the volume by using your middle mouse button. It navigates very similar to SolidWorks, but if you want to pan, you have to use the control key and kind of drag your icon around. Now, this is your base plane that we're going to be working from, and we're going to start by doing some simple sketching and some extrusion just to give you a feel for it. But remember, I do recommend SolidWorks. So we're going to start by specifically drawing a rectangle. So I grab the rectangle tool, and I'm going to click and drag to create a rectangle. I'll then type the dimensions I want for one side, hit Tab, type the dimensions I want for the other, and hit Enter. If you don't do that, you actually can't redimension a drawing after it's been drawn, not in any way that I've been able to figure out. To extrude this, I'll grab the Pull tool, and I will click on the area I just made and extrude that portion. With that in mind, the next step is to choose our actual dimensions here, so I will type in the dimension I want, hit Enter, and that is my final part. If you want to add features to this part, you can choose a face and then draw the feature you want, and then you can pull to extrude or extrude cut that same shape. Once that shape is made, the next step is actually going to be to delete it, because I would like to import something from SolidWorks. So I'm going to select the whole shape, hit delete, and then go up to my menu in the upper left-hand corner. In this menu, I'm going to import a file, and specifically, I'm going to grab a SolidWorks file I made before. Discovery will import this file with the relevant dimensions and spit it out. In this case, the origin of the file matches the origin of the import because I made this around the origin in SolidWorks, but it's good to go. I'll also save this file to make sure that it is ready for use just in case the import doesn't behave itself. So I'll just give it a generic name, and you'll see here in my tutorial window that, or rather in my model window, that I have that little check there, which tells me that that system is ready to go, which is great. So from here, I will double click on the next question mark, and I will wait for the software to load. This is going to load the actual testing software for Ansys. So yet a third piece of software is going to start running. And what that's going to do is it's going to make it possible for us to actually start doing analysis on our part. So once that loads, you're going to be met with yet another void, but hopefully if everything behaves itself, we should see our model load in shortly. And you can see down in the left-hand corner that little loading bar tells us how things are going, and here we go. Here is our part. Now, the movement is the same as in the discovery software, so you can pan, click, rotate the whole 9 yards the same way. In general, what you want to pay attention to is that too much motion in the software can be a little bit jarring, so try and keep your sample relatively centered. On the left-hand side, you can see all of the information we need for our models. We can see that the materials that we needed are already loaded, and we can see that the body and all of the pieces that are required have loaded in properly. So we got those little green check marks. Down below, we can see all the things we need to add, including developing our mesh, as well as developing the actual study itself. But we now know that everything is where it needs to be. So I'm going to start by setting up my sample now. The first thing that I'm going to want to do is I'm actually going to want to start defining information about this. We'll see here that our model's already loaded properly, so I'm actually going to take a look at our materials, and you can see that we can actually check to make sure that all of our material properties have loaded. They have. That's normal to and to be expected. And then I'm going to actually end up assigning a material. So I'm going to right-click, and I'm going to create a material assignment, and you'll notice that from here, what is actually happening is that I have these two little icons in the lower left hand that have gone red. And these are actually what is going to tell me what I have to choose. So I have to choose a body for this as well as a material as I move forward. You'll notice that the little icon next to the material selection is also not a check mark, so that is something that I want to update. So let's first start by choosing the body. So I'm going to go grab the select tool up here in the dead center. Right now it is chosen as auto select, and you'll notice that just grabs a face. It drives me nuts, so instead I'm going to actually just choose the volume. So I'll grab that guy first. So if you take a look up here, grab the volume, click on my part, and if I go over to this first red icon asking me where things are, I will hit apply and yes, and now that body is now set as the thing I'm working on. Then I will choose a material. So in this case, I'm going to choose, just as we go through, and just pick that first material in my list, and that material is now set. And you can see that little green check mark has been applied as well, so we know that that is loaded properly. Now what we're going to do is we're going to actually add our own origin. Right now this part loaded in with its origin from SolidWorks, which is in the center of the part. That's not great for us, so we're going to create a new origin. And this is going to be our working origin. So the first thing I'm going to do is I'm going to choose the corner that I want to be my origin. It doesn't matter which one I pick, I just need to be consistent. So I'll choose the vertex tool, and I will choose my corner, and I will set that to be the location of my axes. And you'll see that right now it is loaded in my X, Y, and Z axes on that lower left-hand corner. But I actually do want to make sure that my X and Y are pointed in different directions. So what I'm going to do is I'm going to manually set that by choosing an edge, and I'm going to choose the edge tool for that. And click here and hit apply. And what that's going to do is bring my X in line. And then what I'm going to do is I'm also going to do the same thing for my Y origin in order to drive my Z in the correct direction, because right now I don't like that it's pointing in down. So I will go through, grab the setting that I need, click on it, let it know that I'm defining it from the geometry, click that edge, hit OK. And you can see now I've got my X, Y, and Z pointing out. For me personally, this is just how I'm going to set up this part. It doesn't matter as long as you are consistent, but you do want to make sure that you're setting your own origin. This is just something that I've been doing since I started machining many years ago, and I recommend it all the time. So I'm just going to give this a custom label because it makes my life easier. The next step is going to be making a mesh for this part. So what I'm going to do is just align my sample a little more clearly. And then I'm going to go over here onto the left, and I'm just going to generate the default mesh. And the default mesh in general tends to be a pretty good baseline most of the time. So you can see that this is the mesh that has been created by the software. The mesh, remember, represents the finite elements of the finite element modeling software. For me right now, I'm noticing that this mesh is a little sparse just because we have this interior feature, so I am going to want to refine it. In order to do that, I will need to increase my mesh density, and I tend to increase mesh density based on a location. So I'm going to specifically refine my mesh by choosing some faces to work with. So I'm going to choose the face tool and then hold down control and choose the edges of my part. And the reason for this is that that's where I expect the most information to be important to me. So I'm going to hit OK and regenerate my mesh. Once I turn this up, I'm going to turn this up 1, 2, 3. Yeah, that works for me. And run it. And what this is going to do is it's going to increase the density of the mesh, and in particular around the areas that I highlighted, so the edges of the part. So if you take a look here, you can see that it is a lot more defined in terms of overall pieces, and also that the edges of the part are a lot more aggressively defined than they were before. So this is ready to go. I'm actually going to tab over to SolidWorks real quick because I want to show you guys how the fixturing that we're about to do works. So in general, when we are looking at the XYZ plane, it's a bad practice to fix one end, and I'll show you why that is at the end. Instead, we want to do realistic boundary conditions, and so I wanted to animate that for you, and this is just the best way I came up with. So the first thing we're going to do is fix a corner to a corner of the part, which SolidWorks naturally does not want to do. So I'll just choose this corner. And the idea is that we want to basically create a pivot point. If we were to fix the entire bottom side, we would actually have a lot of discontinuities because there's basically just a place that cannot move. There's no way to really create that. So instead we create this little pivot geometry that allows our part to freely move without causing basically any strain or stress on the part as a byproduct of just its existence. Then what we'll do is we'll pin one edge, and what that's going to do is it's going to make it possible for us to basically lock that corner down. But it will mean that our system will freely rotate about the axis that we just pinned. Finally, what we'll do is we will pin the bottom edge to the bottom of that surface. And the benefit of doing these two basically parallel mates and a fixed mate is that there's no extra stress added to our part when it's under loading. And so this part is now fully defined, it can't go anywhere, but it also doesn't have to worry about any additional stresses as a byproduct of its construction. So we're going to do the same thing in Ansys, so I'm just going to tab over there real quick. Back in Ansys, I'm going to right-click, insert, and then add a fixed support. And so I just want to make sure that I'm choosing the location of my origin. So I'm just going to double check that real quick by actually clicking on the origin that I pre-set up. And that's right there. So I will go back, choose the point tool, and hit OK to set my new fixed location. So remember, in SolidWorks, this part would now be able to rotate around just that simple point. The next step is going to be specifically adding in that edge. So what we're going to do is we're going to right click again, and I'm going to choose a 0 displacement. And I'm just going to double check to make sure that I am aligned with the part that I want. I'm going to choose the edge, and then I'm going to specifically set the Y and Z displacement to 0. And the reason is that this is basically the same thing as creating that hinge we just talked about in SolidWorks. So the last thing that we're going to want to do is we're going to want to modify the face of this part. So what I'm going to do is I'm going to insert another displacement, and I'm going to choose specifically the face of this location and tell it that it cannot move in the Z direction, so it can't lift off anymore. And that actually fully defines our part. So the last thing we need to do is to add the loading. We are doing tension, so I'm going to insert a force, and I'm going to specifically choose a force along a face, click on the top face, and I'm going to choose that face just by hitting apply. From here, the next big step is to choose the magnitude of the force, and it's right there, and you can actually see which direction the force is pulling. If it's pulling in the wrong direction, you can change that in the settings below. Now it's pretty much home stretch. We're going to add in a bunch of studies, so I'm going to add in a displacement study, a stress study, and a strain study. And these are kind of the standard ones we're going to use for this entire class because it's going to give us the baseline for how this is behaving. And you can see in here there's a ton of other studies that we can go for, so don't limit yourself if you have interest in how some of this stuff works. So the next steps that you guys are going to be taking is we're going to actually run this study. And what you're going to do is just hit solve. And hopefully, if everything behaves itself, we should get a result. But unfortunately, or fortunately, depending on how you're looking at it, we have a solver pivot warning. And this is the most common error you guys are going to have. It just means that your boundary conditions are wrong. So before you reach out to us, double check and see if your boundary conditions are properly lined up. In this case, and I'm wondering if any of you caught this when I was setting it up, I forgot to include the proper origin for one of my displacements. So if you click on that, you can actually see that it's originally at the center, and I can modify this and say, hey, you are supposed to actually be this origin. You may have made a different error. It may just be that you chose the wrong displacement of 0 for different parts. It's important that you check that, because that's probably the most common error that we end up seeing from students when they come to us. So I'm going to rerun the study. And once it's done running, you can see over on the left, everything resolved properly. I've got my green check marks, so I can click on things and figure out where they went from there. In this case, my displacement study shows a pretty clear long displacement at the very end of the part. This is what we would expect. I should hope that the direction of pull is where we're going to see the most displacement. You can see the stress and strain on this part as a function of each individual element. And what I want to stress here is that a lot of these parts, we're looking at either an average or a range. This isn't a perfect measurement. It's not any better or worse than a hand calculation. It's just a different calculation. So in this case, we have a stress concentrator in the form of a circle, and you can actually see how that affects the part's behavior. So the next thing I'm going to do, and actually I'm going to focus on something else first. We're going to change the material of this part just real quick so you guys get a feel for it. So I'm going to right click that material property, and I can just go down here, choose a new material. I'll go with the second and run this one more time. And just like that, I have a totally new study with a new material that I can do the same analysis on and say, hey, how does this change in material affect the stress, strain, and general behavior of my part? And what you're going to find is that in general, for parts of the same geometry, you shouldn't see a change in stress, but you will see a change in strain. And the byproduct of that is just because of the Young's modulus of the part. The final thing I'm going to end with for you guys is to show you why we don't just constrain one end of the part and just lock it in place. First and foremost is it's just not realistic. So I'm going to suppress these guys, same as in SolidWorks. I'm just pushing them down, and I'm going to fix this face. And the reason we don't do this, and it's going to be not as dramatic on this part as perhaps just a pure square bar, is because when we run this study, what you're going to find is that those bottom corners, because they're literally locked in place, can't displace the way they would in the real world. And so as a byproduct of that, we have these stresses that exist in the bottom corners that would not exist in a model that we would do our normal calculations for. And this discontinuity is a huge problem when it comes to analyzing results because they can be local maxima, and that causes a huge headache. So this concludes the tutorial. If you guys have any questions, feel free to reach out. You guys have my email and you guys have Discord. Feel free to let me know. Make sure to save every study after you've done it. It's a good habit. Make sure that you have a copy of it for your records. And if you have any questions, feel free to reach out. Have a good one, guys.